Hello students, this is Miss Medina and I'm going to explain to you projectile problems using that can be modeled using quadratic equations. And the first example that we have is a ball that is being shot from a cannon into the air with an upward velocity of 40 feet per second. The equation that gives us the height, h of t, of the ball at any time t is this one. Now I want you to visualize the flight path. You have a cannon and you fire the cannonball and it's going to rise into the air. At some point it's going to reach a maximum height and then gravity is going to force it back down until it hits the ground. So this is the ground. So this is a parabolic shape, and what you can see is that the maximum represents the vertex and that the ground represents the roots. Okay? And over here at some point you'll also touch, and that'll be your root. That's be your initial height. So this parabolic shape is modeled by this, and this is a very typical equation, and you'll learn more about this in your physics class. H of t is the height. Negative 16 is a value that represents gravity. It's negative 16 when you're using feet and negative 4.9 when you're using meters. 40 represents the initial velocity, and 1.5 is your initial height when time was equal to 0. Okay? You need to understand these functions. This function, your input is time. When you plug time into the function, your answer is the height. Now that you have a mental picture of what's going on, let me break it down for you, the types of questions that you're going to get. And there are usually 5 types of questions that you get. The first one is they give you the input and they want the output. So literally, what is the height of the ball 0.5 seconds after the launch? This is the input. This is your time. And they want the output, your h of t. Another way of thinking about it, this is the x and this is the y. And so how do you solve this problem? You plug into the function. You plug into the function, so you find h of 0.5. So negative 16, 0.5 squared, plus 40 times 0.5, plus 1.5. You type that into your calculator and you get 17.5 feet. So for this question, when they give you the input and they want the output, all you have to do is plug into the function. The second type of problem that they might give you is they'll give you the output and they'll want the input. So for example, how long does it take? So time is the unknown here. For the ball to reach a height of 20 feet. Now this is your height, which means this is the output. So the function equals the height, and the height is 20. So you set the function equal to 20. You get 0 on one side. You set the function equal to the output, get 0 on one side, and then you use the quadratic formula to solve. So let me show you what I mean. 20 equals negative 16 t squared plus 40t plus 1.5. And then we subtract 20 because we want to get 0. We have 0 equals negative 16t squared, 40t minus 18.5. Now you're going to use the quadratic formula to solve for t. You have to get your a, b, and c, your discriminant, and you have to plug in. So a is negative 16, b is 40, c is negative 18.5. And when I plug into the discriminant, I get 416. Next, you're going to plug it into the quadratic formula. So you have negative b, negative 40, plus or minus the square root of the discriminant, which happens to be 416, over 2 times a. And now I'm going to use my calculator and I'm going to find my x values. After I use the quadratic formula, I find that it is 0.6 seconds and 1.9 seconds. Now, why do I get 2 times? Well, think about the trajectory of the ball. The ball rose. At some point, it hit a height of 20 feet, and that was at 0.7 seconds. But then the ball kept on rising. It hit the maximum, and then it came back down. And at some point, when it's way back down, it was also at 20 feet. And that was at 1.9 seconds. And of course, it kept going until it hit the ground. So there's actually 2 times when the ball was at 20 feet, when it was rising and when it was coming down. So that's why you get 2 separate answers. The third type of problem that you're going to be asked to solve is to get information about the maximum or the minimum, also known as the vertex. So the questions might ask you about what is the maximum height attained by the ball? Or at what time will the ball be at its highest point or the maximum or the greatest point, right? So here they're asking you about the height or the y value, and here they want the time at the highest value. Once again, I'm going to use negative b over 2a, and then I'm going to plug it into the function to get that value. Okay? And so finding negative b over 2a, and I'll always go back to the original equation, right? Always go back to the original equation. I should have written it down. Hold on one second. Alright, I wrote down the equation, the original one. And so I'm going to get negative b over 2a. So negative 40 over 2 times negative 16. Right, and I find that this answer is 1.25 seconds. And then I'm going to plug this into the function. So it's negative 16, 1.25 squared, plus 40 times 1.25 plus 1.5. And when I plug that into the calculator, I get 26.5 feet. You can double check. Please make sure that you're double checking. Alright, so the vertex, you still see? Yes. Is 1.25 seconds and 26.5 feet. So the answer to 3A, what is the maximum height attained by the ball? That's 26.5 seconds. At what time would the ball be at its highest point? 1.25 seconds. And that corresponds to this point right here. At 1.25 seconds, the ball is at 26.5 feet. How long does it take for the ball to reach the ground? Well, this is information about the roots. So now you're solving for the roots. Remember, there's like 4 different ways for you to solve for the roots, and I'm going to stick to the quadratic formula here. So what they want you to do is they want you to take the original formula, and they want you to set it equal to 0. Because that's when it's going to be touching the ground, when y equals 0. And then you're just going to use the quadratic formula. So I'm going to list my a, my b, and my c. I'm going to find my discriminant, and I'm going to use the quadratic formula. So I'm going to pause the video, and then I'm going to show you when I continue. A is negative 16, b is 40, c equals 1.5. I check the discriminant, b squared minus 4ac. When I plug the values in, I get 1696. That means I have 2 real roots. I plug into the quadratic formula, negative b plus or minus the square root of the discriminant over 2 times a. And when I use the calculator, I find that I get negative 0.04 seconds and 2.54 seconds. Alright, so negative time is invalid, so that doesn't make any sense. So at 2.54 seconds is how long it'll take for the ball to reach the ground. So the ball's going to rise, come down, and at 2.54 seconds it's going to reach the ground. It'll be at a height of 0. The last type of question that they might ask you is, what was the initial height of the ball? So they want to know the height when time equals 0. So all you do is you plug in 0 into the function. 40 times 0 plus 1.5, and you get 1.5 feet. So anything about initial means that time equals 0. So let's do a quick recap. If they give you the input and they want the output, all you got to do is plug it into the equation, into the function, and you get your answer. They give you the output and they want the input. Notice that this is the one that has the most space. What you do is you set the function equal to the output, and then you move it to the other side, and you get a 0. And once you have a 0 on one side of the function, you go ahead and use the quadratic formula to solve for your answers. The next type of question is questions about the vertex, so maximum height, or sometimes it'll be minimum, but for projectile questions you always have maximums. So I use negative b over 2a to find the vertex, and you just got to be careful. What are they asking you for? Are they asking you questions about the y value or the x value? They might want information about the roots. So how long does it take for the ball to reach the ground? You got to remember that the ground is the roots. Okay. And to set the function equal to 0, the original function equal to 0, and you use the quadratic formula to find your answer. And you disqualify any questions, any answers that don't make any sense. And sometimes they'll want information about the initial starting point, and that means time equals 0, and you just plug it in and you get your answer.